Alright, what's up guys? In this video, we're going to pick up with some multivariable calculus, and we're going to be talking about how to find the angle between two vectors. So we're given here these two vectors u and v. We're given u is equal to I minus 2j minus k, and v is equal to I plus j plus 2k. They want us to find the angle between these two vectors. So this is not hard to do. So recall that the definition of the dot product is if I have two vectors, in our case we'll just say u and v, and I want the dot product of those two vectors will be the magnitude or the norm of the first vector u multiplied by the magnitude or the norm of the second vector v multiplied by cosine theta, and theta is the angle between them. Alright, so if I solve this equation for cosine theta, I'll get cosine theta is equal to the dot product of u and v all divided by the magnitude or the norm of u times the magnitude or the norm of v. So this is what we would use. And then once we have taken care of all that, we will take the inverse cosine, and that'll give us the angle. So let's just begin by calculating the dot product, basically. So remember that, as you can see here, we got I, j, and k. So remember, unit vectors are dimensionless vectors with a magnitude of 1. So anytime you see a unit vector sitting by itself, it's just 1. So in this case, if we take the dot product, what we're really doing is taking the dot product of 1, negative 2, negative 1, and we're dotting that with 1, 1, and positive 2. So that's just going to be 1 times 1 plus negative 2 times 1, and then plus negative 1 multiplied by positive 2. And in that case, we simply get 1 minus 2 minus another 2, which just gives us negative 3. So that's actually the dot product. And remember, when we take the dot product of two vectors, we get a scalar. So we get negative 3. That's the dot product of the two vectors. Remember, if you take the dot product of two vectors and it's 0, then it's orthogonal. Okay, that really doesn't have much meaning here, but I just wanted to mention that. All right. So the next thing is to calculate the magnitude, or the norm. And that's just the square root of the sum of the components squared. So we got the square root, and so it'll be 1 squared plus negative 2 squared, and then plus negative 1 squared, and we see what we get. And so in that case, we get 1 plus 4 plus another 1. And this will give you the square root of 6. Sorry for the noise in the background. Those are my nephews. They're 3 and 4 years old, so bear with me on that. Sorry about that. Alright, so that's the magnitude of the first vector. Let's find the magnitude of the second vector. So the magnitude of the second vector, again, same thing, square root of sum of components squared. So it's going to be 1 squared. We got another 1 squared, and then we got 2 squared. And if you notice here, we're actually going to get the magnitude of these vectors is going to be identical. Okay. All right, so we're going to get the square root of 6 for as the magnitude or the norm for each of those vectors, which actually works out well for us. So what we got now is cosine theta. And remember, when we solved this equation for cosine theta, we got our dot product, which was negative 3. When we found the norm of these vectors, or the magnitude, we got the square root of 6, and we're going to multiply that by the square root of 6. Now remember, the square root of 6 times the square root of 6 is just 6. So this is essentially cosine theta is equal to negative 3 over 6, which we know we can reduce down to negative 1/3. So we would just get cosine theta is equal to negative 1/3, and we just need to take the I'm sorry, not negative 1/3, negative 1/2, excuse me. I don't know where I got negative 1/3 from. Negative 1/2, sorry. So now I just take the inverse cosine. So theta would be cosine to the negative first of negative 1/2. I said negative 1/3. Apologize. Negative 1/2. Excuse me. Long day. Bear with me on that. All right. So what is inverse cosine of negative 1/2? Well, in radians, it's just 2 pi over 3. And remember, 2 pi over 3, if we need to think about it in terms of degrees, because obviously that's what we want, that's just 120 degrees, basically. So theta is actually equal to 120 degrees, and that would actually be the answer. So your final answer here, and our angle between these two vectors is theta is equal to 120 degrees. And that is your answer. Alright, so pretty straightforward process if you are cool with dot product, cool with finding the magnitude of vectors and all that good stuff, you will be fine on this. Alright guys, thank y'all for joining. See you next time.